Let's warm up by solving these linear equations. They're linear because the x just has an exponent of 1, and then they're not in the denominator in either of these equations. First, we need to distribute in the coefficient. Remember, we don't do 9 minus 5 first. The multiplying and dividing come before adding and subtracting. We've got 3x minus 12, then the minus 10 on this side, then 9 minus 5x minus 15. Let's collect all the x's on the left side, so plus 5x, plus 5x. This one is minus 22, so let's add 22 on this side and add 22 on this side. So this one all cancels. We've got 8x on this side. And on this side we've got 31 minus 15 is 16. Then divide both sides by 8. And we're left with x is equal to 2. I'm going to do this one two different ways. First, I'll just work on the left side independently. So to add these rationals, I need to have a common denominator. So I'll multiply the numerator here and the denominator by 4. That will give me x plus 6 plus 4 all over the common denominator of 4. Next, I'm going to cross multiply, or essentially that means I'm going to multiply both sides by 3. And I'll put brackets around this just to make sure we understand those are together as a family. Get rid of that 3. Then I'll multiply both sides by 4 to get rid of the denominator on this side. Then I'm going to collect up like terms here. So 3 times x plus 10 on this side. And on this side I'm already good. Next, distribute in these numbers. So 3x plus 30 is equal to 20x minus 4. Let's collect up the x's on this side, so minus 3x on this side and this side, and add 4 on that side and this side. That means we get 34 is equal to 17x, and divide both sides by 17, we get that x is equal to 2. Now if you look back, we have, during this step right here, multiplied by 3 and 4, which is the same as multiplying by 12, and that is our lowest common denominator. So a different strategy would be to multiply by the lowest common denominator right off the start. Let's redo this question doing that. So it's x plus 6 over 4 plus 1 is equal to 5x minus 1 over 3. And the lowest common denominator here would be 12. I'm going to multiply each of these terms by 12. This term here, the single term there, and that term over there. So 12x plus 6 over 4 plus 12 plus 12, 5x minus 1 over 3. Now I can simplify this. 12 divided by 4 is 3. 12 divided by 3 is 4. I can distribute the 3 and the 4 in. So 3x plus 18 plus 12 equals 20x minus 4. I'm going to collect up the x's on this side, and it's going to start to look very much like that first method we already did. Plus 4 on both sides. This side would add up to 34. This side would be 17x. Divide both sides by 17, and we get x is equal to 2. Why might we want to do it this way? Well, in one step, we get rid of all the denominators, and that simplifies the question. This also took, after the question, 4 steps, whereas this took 5 steps. But I suppose that you could skip steps and make it shorter as well. 6.4a rational equations. We're going to split 6.4 into two sections, one without word problems, and the next section will deal with word problems. For solving these given equations, factor everything if possible, state the non-permissible values before you get rid of that information, multiply both sides by the lowest common denominator, solve for x, check for extraneous roots. I put this step number 3 here just in case you're stuck. But really, it could just say, do algebra to solve for x. Let's see how that might look with the first example here. We have just x in the denominator, so I'm going to make a note that x cannot equal 0. Now I'm going to multiply by my lowest common denominator, and my only denominator, in this case, so multiply by x. So I'll get 10x plus 2, because here the x's will cancel, equals 8x. Next, I'll collect up the x's on this side, so minus 8x here and minus 8x here, and I'll collect the numbers on the right side, so minus 2 and minus 2. That gives me on this side 2x, and on this side negative 2, divide both sides by 2, and I get x equals negative 1. And I just check my non-permissible value. Couldn't equal 0, and it doesn't, so this looks good. Let's do this question a different way, because really if you thought of it a different way, then that's probably the right way. So whatever algebra you think of, do that. So maybe we see that we have a 10 and an 8, and we might as well collect those up because they're like terms, so minus 10 on both sides. This gives us negative 2. Now we can multiply by x on both sides to get rid of it there, and divide by negative 2 on both sides. And they end up with the same answer, just different algebra. And again, it doesn't matter what algebra steps you take, as long as they're correct algebra. So the next question I'll do two ways again. First way, I'll multiply the whole equation by the lowest common denominator. In this case, that would be 8m. So I'll multiply the whole equation by 8m. And then just rewrite it with the 8m being multiplied in each term. You could simplify that in the first step if you wanted. M times 7 divided by 8. In the first term here, we're going to have the m's cancel, and 8 divided by 2 is 4. Second term here, we'll have the m's cancel. Third term, we'll have the 8's cancel. So now we'll multiply in the 4 into the binomial, so 4m minus 12. Then we'll multiply the 8 into the binomial, so 8m minus 8. And 7 times m is just 7m. Now we need to decide which side we're going to collect up our m's and which side we're going to collect up our numbers. And it doesn't matter. I'll collect up the m's on this side since there's more of them on the left. So minus 7m on that side and this side. That gives me 12m minus 7m is 5m's. And then I've got a minus 12 and a minus 8, so that's minus 20. So to get rid of that, I'll add 20 on both sides. So I get 5m equals 20. And then divide by 5. That means m is equal to 4. Now doing a quick check, I had m in the denominator here and here. That means that m should not equal 0. And I didn't come up with m equals 0, so the solution is fine. I'll do this question a different way. Most people like to work with just one side at a time, so I'll do that. So I've got m minus 3 over 2m plus m minus 1 over m equals 7 over 8. And to get these two terms to have the common denominator, we'll multiply this one by 2, numerator and denominator. Now I've got m minus 3 plus, and I can multiply in the 2m minus 2 all over our common denominator of 2m. I can collect up the like terms on here. We've got m and 2m is 3m's, and minus 3 minus 2 is minus 5. And then we can do what's called cross multiplying. That will mean we have to simplify more. So we could use the lowest common denominator in this step, which would be 8m. But let's cross multiply, since I think a lot of students would do that. So multiply both sides by 2m and multiply both sides by 8. And then we have 8. Remember, that's a binomial family, so 8 times 3m, 24m's. 8 times minus 5 is minus 14. This side we got 14m. Let's subtract 14m on both sides and add 40 on both sides. This would be 10m equals 40. Divide both sides by 10, and m is still equal to 4. Either way we do it, we're going to get the right answer because we're doing correct algebra steps. Also, we have this restriction here, m cannot equal 0, and it doesn't, so we're all good. Example 3, our first two terms are already factored, they already look nice, but this one needs factoring. So let's do that first. Not changing anything on the left side of the equation, just going to factor the right side. So y minus 6 and y minus 3. Okay, now I can make a note of my non-permissible values. In this equation, y cannot be allowed to equal 3 or 6, because then we'll be dividing by 0. Now, let's get rid of our denominator in one step. Let's multiply this whole equation by y minus 3, y minus 6. So in the first term, the y minus 3's cancel, and we're just left with a y minus 6. In the second term, the y minus 6's cancel, and I'm just left with the y minus 3. And in the last term, on the right side of the equation, both the binomials cancel, so I'll just be left with 18. Now I can distribute in my coefficients of 9 and negative 4. So I've got 9y minus 54 minus 4y plus 12 equals 18. Let's collect up the y's on the left and the numbers on the right. So I've got 9y minus 4y is 5y's. I've got minus 54 plus 12, and negative 42, so we'll have to add 42 on both sides to get rid of it on the left. Add 42 here, means it's 60 on the right side. Divide both sides by 5, and we get y is equal to 12. And y is equal to 12 is a great answer. It is not one of our non-permissible values here, so it's good. Let's start this example off with factoring. So on the left side, we've got 3 is fine, but there's a common factor here, x, leaving us with x minus 1. 5 over x is fine, and this one's almost fine, except this is 1 minus x, and I see an x minus 1. So I'm going to factor out a negative so that this becomes x minus 1. And that way they're the same, and then I'll have a common part of my denominator here. I'm also going to take this negative and combine it with this negative, make it positive. I think that'll be easier as well. So for this side, plus 3 over x minus 1. Now I'll do my non-permissible values. So x cannot equal 0 and 1. because then we'd be dividing by 0. Next, I'll multiply the whole equation by our common denominator. And our common denominator in this case would be x, because we have an x here and here, and x minus 1. So for the first one, the x and the x minus 1 will cancel, and I'll just be left with 3. For the next one, the x's will cancel, but not the x minus 1, so that will show up there. And the last term, the x minus 1s will cancel, but not the x, so we'll just be left with 3x. Multiply in the 5, 5x minus 5 plus 3x. And now let's collect up the x's. Let's do it on the right side here, because we already have them all here. 8x, and then add 5 to get rid of it here, add 5 here. That means that we have 8 equals 8x, divide both sides by 8, we get x is equal to 1. And then you might think that you're done, but we need to check our non-permissible values, and earlier we said that x could not equal 1. That means that we'll put a line through this, and we'll call this extraneous or extra dangerous, because we've algebraically found a solution that's not really a solution. So this would have no solutions, because the only solution we found turned out to be extraneous. The sum of two numbers is 4. The sum of their reciprocals is 4/3. We need two variables here. Let x and y be two real numbers. And the first sentence translated into math would be x plus y is equal to 4. The second sentence, the reciprocals, is 1 over x plus 1 over y, and that adds up to 4/3. Now we have two equations with two unknowns. That means we can solve this. Let's sub out y into the second equation. So we have y equals 4 minus x. We'll replace this y with 4 minus x. Next, let's get rid of the denominator in this equation by multiplying by the lowest common denominator. They've got nothing common, unfortunately. So let's multiply by 3x and 4x, 4 minus x. In the first term, the x's will cancel, but we're left with the 3 and the 4 minus x. So 3, 4 minus x. In the next term here, the 3 and the x will show up, and the 4 minus x and the 4 minus x will cancel, so it won't show up. Then we've got the 3 and the 3 will cancel. There's a 4 already here, so 4x and 4 minus x. And now in one step we've gotten rid of the denominator, and usually once there's no denominator, then students don't have a hard time solving it from here. Let's multiply in the coefficients, so we get 12 minus 3x plus 3x equals 16x minus 4x squared. First thing we see, minus 3x plus 3x cancels out. The next thing we see is this entire equation has a common factor of 4. Let's get rid of that, just to simplify our numbers. And we have 3 equals 4x minus x squared. Now let's collect all the terms on this side. I like a positive leading coefficient for my x squared. So x squared minus 4x plus 3 equals 0. Just moved all the terms over here. I'm going to solve this quadratic by factoring it. X minus 3, x minus 1 equals 0. That means that x equals 1 and 3. So we found two potential solutions for x here. Now we need to find y. Remember, y was 4 minus x. So when x is equal to 1, then y is equal to 4 minus 1, which is 3. And when x is equal to 3, because we had two solutions here, we're finding two values of y. Y is equal to 4 minus 3, which is 1. Now we see that this one gives us 1 and 3 as the two numbers, and this one gives us 3 and 1 as the two numbers. So really, mathematically, x and y's were both the same, and that's why it's just giving it to us in two different orders, saying x could be this and y could be this, or the opposite. So we don't need to worry about that. The two numbers are 1 and 3. This was part of algebra and number 6, solve problems that involve rational equations, limited to numerators and denominators that are monomials, binomials, or trinomials. So if you ever get a complicated cubic expression, probably you forgot to simplify. Try these questions, see if you know what you're doing.